Yeah, I'm going to be talking about stuff which is pretty similar to what the other speakers have talked about, though my perspective might be a little different. I'm kind of doing this stuff from the trenches, so the tips that I want to give you are kind of from that perspective. But the idea is the same. We want to behave in a little bit of a smarter way when we are doing data science. Just because it's a relatively new kind of phenomenon doesn't mean that we should just blindly do things without thinking. And so a little bit about myself. I do a really good American accent. So I actually was a scientist before I got into this industry. I was a material scientist, and I spent my days in the basements of government laboratories, far from the sun, in front of the green glare of the electron microscopes, giant microscope as big as this, as big as this room. And we shoot the electrons through thin pieces of material and watch how they bend. And that's what I did for days and days and days, for years and years and years. And then I realized I wanted to go outside. So I transitioned to data science with the Data Incubator. The Data Incubator is a data science training organization primarily. And we are mostly known for our fellowship program, where we take PhD and master's students who want to transition away from academia toward data science. And we give them a free pass to our 2-month boot camp, where we teach them the skills which we think that they don't, the skills we think they need to know in order to become competent. And the learning philosophy that we have is essentially that we want to let people teach themselves. We want to give people hands-on projects and let them fail at those projects, and then learn how to get out of that failure state. And if you can learn to fail without getting frustrated, without giving up, then you will kind of get on this path where the obstacles kind of become fun, and you kind of start allowing yourself to be creative, and you're not afraid to try things that are new. So we make them fail a lot. We give them very difficult projects to do, and we give them very little time to do them. And we try to build this spirit of collaboration coupled with independence. We want people to be independent enough to solve their own problems, but we want them to use other people to help them. And without going into the philosophy of yin and yang, it's enough to say that employers really like this. Employers like people who are capable of doing stuff independently, but also are willing to work as a team. And so I like to say that we're not trying to teach people how to win the Tour de France. We're just teaching them how to ride a bicycle and how to get better at riding bicycles. And by the time they get through with our program, we try to convince employers that they're going to be able to be very good competitors in the future. So we have 250 or more partner companies. It kind of changes. And the incentive structure that we have is, I think, pretty cool. So we have this free program for PhD students who don't have jobs. So they're really motivated to learn. And we have employers where it's free for them to participate in our program. They only pay us if they make a hire. So they're really motivated to hire because they want people who aren't just putting data science on their resume, but people who actually have struggled and managed to complete very difficult data science projects. And so we're very motivated to train people very well so that we can get them hired, so that we can take our Scottish vacations. So that's how the incentive structure kind of works, and I think it's a pretty good. And so we have this core intellectual property of our curriculum, which is this combination of code snippets and ideas and methodology, which we are constantly updating and improving. And that is kind of why I'm here, is that I'm trying to take that curriculum and teach it to people who are just employees at other companies who want to learn some of these skills. Don't need to go through the whole boot camp, but I've been in Edinburgh for the past 3 weeks with the Data Lab, teaching things like data wrangling in Python, machine learning, and this week, visualization. So it's been a great time so far, had a blast. I can echo Steve's comments about how great the Data Lab are to work with. And I didn't have to remember your name because you're all Steve. So what I want to talk about today is this idea of the data pipeline. So as a data scientist, you're probably used to hearing about this idea that the data science algorithms themselves are a pretty small part of the job. You've got to do a lot of data cleaning beforehand. You've got to do the visualization afterwards. You've got to do the storytelling part of it. You've got to think about decision making and business ramifications, strategy, all of that. And that's very true. But even when it just comes to technology, forgetting about decision making entirely, we generally have a lot of different steps we have to go through to get something that's an actually working product. We have to ingest data from somewhere. We have to keep that data somewhere. We have to move that data around to different people. We have to give some kind of means for them to explore it. It has to be cleaned, it has to be processed, it has to be analyzed, modeled, iterated over, visualized, all of this stuff. And while there are companies that say they will do all of this for you, often you want control over these parts of the process, and perhaps you want to build a specialty in one or more of these areas. So what I want to talk to you today about, pretty briefly really, because I want to give time to Brainwave, because I hear they had a big day today, is how do we build these pipelines in a way that we can change them without breaking stuff? How do we scale up these pipelines to deal with more data in a smart way? And this pipeline itself is kind of a project that has to be managed. So I'm kind of talking a little bit to project managers here and people who are a little bit higher up as well. It's really not enough to come up with a pipeline that you like and say, great, we've figured it out. And we have our pipeline, we have our data coming in here, it goes through this, it goes through Spark, we print it out, and then we bind all that stuff into a book and we ship it to our clients, and we're done. Because one of the core cultural principles of data science is this idea of rapid iteration. We're always pushing for new things, new technologies. There's always some kind of external demand for some new functionality, or if it's not external, it's coming from inside the company. They want to do something new. Maybe somebody in a meeting is like, wouldn't it be cool if we could, instead of binding the book, actually put it in an email, then we wouldn't have to print out all this paper. That would be cool. What would that involve changing? And then there's always the kind of comments that are like, well, so-and-so uses this, we should too. Google uses MapReduce, we should use MapReduce. And those also make people think. But changing the way things work always incurs costs. And this is something which I think often goes under the radar because people are very proud of the new technologies which they've deployed in their company. They're very proud of the thing that they've set up. And they often don't appreciate that for those of us in the trenches, every time you introduce some new technology, there's some price that has to be paid. You often break all the integrations that you had with the other pieces of your pipeline. You often invalidate the old knowledge and experience and know-how that you've built up internally. How to fix problems, how to fix something when it breaks. You have to learn that stuff all over again. And you often have unexpected repercussions. So you might find out maybe weeks or months later that because you changed one thing, all of a sudden your backup data isn't storing the way that you thought it was. And now your backups for the past month are gone. So I want to talk about how we future-proof our pipelines. And I have 5 tips that your competitors don't want you to know about. It's maybe a little bit better than BuzzFeed. So the first tip is to consider the implications across your pipeline. If you imagine that every piece of technology you have is connected to other technologies in the chain, when you take one of those links out and replace it with something else, you don't just affect the things that are adjacent to it, you may affect the other parts of the entire system. And your overall capacity is not dictated by a weak link that you can replace. It's dictated by all of the pieces working together. So, for example, a common workflow is to get some data in, do some modeling using Python or something like that, and then use that model to create some kind of visualization for a client, and then maybe you've got a web page where that visualization is updated in real time as data comes in. Well, I can't just change the modeling piece and expect everything else to stay the same. I did a project where, they had a very simple model. They wanted to do a more fancier model, like a neural network instead of linear regression. So they did a neural network. Well, the neural network actually takes a lot longer to make predictions than linear regression because the data has to be processed by this neural network before you can get the prediction out. That meant that instead of having a smoothly updating visualization on their website, now they have a visualization that updates like every few seconds. So what they did affected the job of the front-end engineers, and they had to work like extra hard to get it to be like really smooth and good-looking again. So a lot of production workflows require this degree of interconnectivity. You can't just expect that the best machine learning software is also going to handle your visualization for you or your website. So you have to have these links, and that means that changing one thing changes all of the other things in some way. And the other point I want to make here is that the connections often exist between people as well. And these are connections that, if you're becoming an expert in machine learning or an expert in linear regression, you get to know the engineers very well. You've been working with them for a long time, getting the right data for your kind of model. All of a sudden you switch models. Well, now a new person is in charge of the modeling. Now they've got to build a new relationship between these two people. And that's something that takes time. Often it's the efficiency of these connections which I see mattering a lot. The strength of the relationships, which actually makes things flow really nicely, as opposed to just the raw capabilities of any one piece of technology. The second tip is very similar to what I've heard here already tonight, which is identify what you want from the store before you go shopping. My advice to anyone doing data science is to forget buzzwords. They're all about selling you stuff. Forget about hype and all the hottest new technologies. The first thing you have to think about is what you need and what you want to do. Once you identify what you want to do, then you can think about whether or not a new technology is worth it or not. There are a lot of people back in material science who I saw get sucked into this hype train of the fancy new microscope, which they happily sell a new one each year for even, it's millions and millions of dollars for these things. And they'll buy the microscope first and then think of how they're going to use it. And I think that that's completely the opposite way of what you should be doing. You should have some piece of science that you want to do that requires the use of a microscope. Then you go buy it. And older technology often has advantages. I do a lot of stuff with Spark, which is a very popular new way of doing distributed computing. The old way to do it used to be using Hadoop MapReduce, which Google made famous. And in blue, you can see kind of the Google Trends results for MapReduce, and in red is the Google Trends for Spark. And this is about March 2015-ish. So people look at this and they say, oh, Spark is really up and coming. Like, everybody's really interested in Spark. We've got to do Spark. And I look at this and I say, nobody was using Spark 2 years ago. So if something breaks, how am I supposed to know how to fix it? MapReduce has been around forever. People know that inside and out. They know how to fix the problems. There's a huge knowledge base out there. It's very stable. It doesn't change anymore. Spark is changing every month. So this is like a real cost. And that's not to say it isn't worth it. It just means you have to do the cost-benefit analysis. you do have to go shopping eventually, or you're going to starve. So even people who are very set in their ways and very confident that they don't have to upgrade often find themselves forced to upgrade because of just accumulation of data over time. And you don't want to be caught off guard by that kind of thing. You just want to be aware that there's going to be growing pains, there's going to be some productivity disruption, and it's fine to have that. It's easier to justify that to people if you can point to the fact that you've thought of this already, and in the long term you think this is going to be a net benefit. This is a pretty straightforward one, but I think it's important from the concept, from the perspective of data governance. You want to make sure that new solutions don't break your old functionality. You basically have to test, and then test again, and then test again. And then not just test each individual component, but test the integrations between the components. And as a software developer, I really hate writing integration tests. If there are any other software developers here, you probably know what I'm talking about. But they're absolutely necessary for making sure that, especially with sensitive information core to your business or personally identifiable information, like in healthcare or something like that, you really cannot afford to have some change that you make affect that data in an unforeseen way. Now, the really cool part about writing all these tests is that you get to establish a reference of all these test cases, which means all of your employees who've been writing these tests have, in a way, been writing down what they think is important, how they think the product should behave. What are the use cases which are in their heads at the time? And this is kind of like an asynchronous form of knowledge transfer to the people who you hire next year. Because they're going to see those test cases and say, oh, so they were thinking about this, and this eventuality. That's interesting, I never thought of that. So a lot of stuff happens in a very informal way, a very, I don't know what to call it, like a grassroots kind of network, like developer to developer through code. The fourth tip is to establish a feedback loop. Feedback is really important regardless of what you're doing. It's particularly important when you've just changed something, because if you can establish a metric that determines how well the change is going, you can feed that back into your decision making for how you're going to go about making future changes. And not only that, but establishing a feedback and monitoring mechanism often makes employees feel supported. Like they're there trying to figure out this thing for the first time, and now they have an avenue for them to say, well, what do they think is going wrong, what do they think is going right? There is this idea, Pareto principle of the 80-20 threshold, where 20% of your effort gives you 80% of the yield, an extra 80% effort gives you the remaining 20% of the yield. It can be hard to figure out where you are in that, like what percentage you're at. How do you know when you're at 80%? How do you know when you're at 20%? Monitoring is one way to kind of get at that. Because if you have some kind of metric that you had from your previous pipeline, you can see if you are meeting those same standards. And lastly, I think that it's really important to focus on the people. This isn't just because I am working for a training organization, but it's because of something which I've noticed for a long time. Material science is a very interdisciplinary science. It's a mixture of physics and chemistry and engineering. And really, all we do is we take the ability to talk to physicists and the ability to talk to chemists and translate between what they're talking about and turn that into a new idea. That idea is not because we're super smart, it just comes about because we can understand both of them. And in a lot of situations, we've built these silos of expertise. Somebody's very good at modeling, somebody's very good at the web, somebody is very good at visualizations. And data science is, I think, in many ways, like material science, in that a lot of the value comes from bridging and communicating between all of those silos. So when it comes to scaling up your functionality as a company, it's really important to have open communication across all departments. Just because we're talking about technology doesn't mean that things like marketing and business development and sales and human resources don't matter. A new marketing initiative that says that they want to put our model visualization hosted on 3 other websites, that actually has implications down in like an engineer's office somewhere. So it's really important to retain the advantage that we have as data scientists of being able to talk to statisticians, being able to talk to programmers, being able to talk to business people, and use this idea of data literacy to give ourselves better perspective on what's going on and better ability to help other people. When something does go wrong because you change something, it's nice if there's somebody next to them who really can talk to, or somebody who can help them. And that comes about when people kind of understand enough about what everyone's doing to collaborate. And I think that along with this idea, there's this idea of you don't want people to feel left out. You don't want people to feel like I'm scaling up my capacity in this way, and we're going to start doing machine learning instead of the statistical modeling we've been doing for a long time. And if I'm a statistician, well, what do I think? We're moving away from like my expertise. Well, you can train those statisticians to do data science very easily. The whole point of our fellowship program is that there's a very small gap between what people already know and what you need to become a data scientist. So don't let people fall through the cracks when you're upgrading stuff. It's kind of the last idea. So I will leave it at that and ask if there are any questions or if you've experienced similar things. And thank you for your attention.